Okay, hello. This is Mr. Lom again, and today we're going to convert on the stoichiometry roadmap from moles to Avogadro's number and Avogadro's number to moles. Now, you know that when we talk about measurements or how much of something, you know that 1 dozen is equal to 12. Well, 1 mole of anything is equal to 6.02 times 10 to the 23rd power. That's a large, large number. So we can say moles of atoms, moles of formula units, ions, and so forth. And you can write this, these are equal, and you can write this as 1 mole is equal to 6.02 times 10 to the 23, or you can put this on top, times 10 to the 23 is equal to 1 mole. Either of those is correct, they're both equal to each other. Now these are a little bit harder because they have this power of 10 in them. And so you got to go back and remember how we did decimals. So anyway, let's start with this first example. Let's say we got 4 moles of carbon. Convert this to Avogadro's number. So we write 4 moles of carbon, put our lines in, and then on the bottom we'll have 1 mole of carbon, and then that's going to be equal to Avogadro's number. This is atoms of carbon. So you write it like that, and we do the same thing, we multiply it out. Now when we do this, we have 4 times 6.02, and I like to separate the numbers from the power of 10, if you don't mind. We can do that, and I think it makes it a little bit easier, times 10 to the 23rd power. So we know that 4 times 6 is 24, 4 times 2 is 8, so it's going to equal to 24.08 times 10 to the 23rd power. Now, since we're dealing in scientific notation, we want to put the final answer in scientific notation. So we're going to move this decimal one place to the left to where we have one number and then a decimal, then the other numbers. So we move it this way to put it there. And so because that number is greater than 1, it's a positive power. So the way that I like to do that then is I'm going to put 2.408 times 10 to the 23 plus 1. I do that because a lot of students will just make a mistake somewhere in the calculation, and I like for you to show every single step, as you guys know. So this is equal to 2.408 times 10 to the 24, and we're in atoms of carbon. And of course, let's put the almighty rectangle around this guy. There you go. And so that's that first problem. This is an A there. Okay, so you start with moles. It's a one-step problem. Put 1 mole is equal to Avogadro's number. Okay, and then you cancel out your units, multiply the numbers just like you did before. The only tricky little thing I do is take out the powers of 10. You can leave it in or you can take it out because you're still multiplying it. And you multiply it out, and there you go, and you get your answer. Now, your homework problem number 14. Convert 12 moles of lead atoms to number of atoms. So you can do it just like this problem here. You're going to start with 12 moles of lead, Pb, put 1 mole of lead down here, put Avogadro's number of atoms of lead up here, then do your math like I did here. Okay? Now, let's do the reverse, shall we? Let's go ahead and convert numbers of atoms to moles. So let's just say we have, and we'll make it easy here, we have 8.9, and in instead of, well, we'll keep it in atoms again. 8.9 atoms of copper convert to moles. So this is example 15. Okay, and so what we're going to do, we'll put our 8.9 atoms of copper and so this time you got to have the same unit on the bottom of that first step. So we're going to put Avogadro's number down here, 6.02 times 10 to the 23 atoms of copper. Now why do we put it down there? Because of the unit that we have up here to start with. We have atoms of Cu, copper, to start with, so you got to have the same unit in the bottom of that first step right here. And so by atoms, we'll go Avogadro's number. And this is equal to 1 mole of copper. You can put MOLE, you can put MOL, you can put little m. It's all the same thing. Put your equal sign, and we are going to cancel that out. Now think of this as fractions. So you got a number on top and the number on the bottom. This is a little bit more involved. So here we got 8.9, the ones drop out, divided by 6.02 times 10 to the 23. Okay, what I would do first is I would do the division of the numbers first. So let me get out my handy dandy calculator on my phone. Okay, and so we're going to put in 8.9 and we're going to divide it by 6.02. That's equal to 1.47. So let's just keep rounding to the 10th here. So it's equal to 1.5 times 10. It's 1.5, and this is still divided by 10 to the 23rd power. So let's move this phone back out of the way. Okay, so what we have to do is we have to move this number on top. Now when you move a power of 10 on top, it switches signs. So this would be equal to 1.5 times 10 to the negative 23 power, which is a very, very small number. Negative powers are small numbers. This one's very small. And we're still going to put our units. We are in moles of copper, so put your M and put Cu here. Now put a rectangle around our answer. Now we did not have to move the decimal here because it was already in scientific notation when we got the answer. But they're not all going to be like that. Okay, and sometimes they have powers of 10 to start with. And when you move the power of whatever, 10 to the whatever power on the bottom, you'll be subtracting or adding, depending on what kind of powers you got. But anyway, that's the answer here. So here is your homework number 15. And instead of 8.9 atoms of copper, let's keep this still on a simple situation. So convert 5.9 moles, and let's say of sulfur. Sorry, we already did that. Let me back up here a second. Let's convert 5.9 atoms of sulfur to moles. There. So atoms to moles. So we'll start the exact same way as we did in this first problem. So you'll be putting your 5.9 atoms of sulfur up here just like this. And then you put Avogadro's number on the bottom because you're going to be starting with atoms of sulfur. So you'll have this many numbers of atoms of sulfur in 1 mole of sulfur. So then you put that in there and you do the math and you'll have your answer. Okay? And these are one-step problems. Thank you. We'll end this video here and we'll go right to the next one.